Hi guys, in this episode we're going to look at solids. Solids use primitive volumes that can be added, subtracted and sliced, put holes through, filleted, and a whole lot of other features to them that can mean that you can make up a whole lot of stuff that is just non-standard, or even things that you want to use regularly. Great for things like balustrades, handrails, picket fences and stairs. I hope you really enjoy the episode as we work through some of those basic principles of solids so that you can apply them to your projects. Have fun. Solids, if you're using them for the right tool for the right job, they're really quite useful. What I'm going to do is start with what would you do with an I-beam. For instance, if you wanted to have an I-beam and draw that up into a solid, the place to start that I would start if I'm wanting to do an I-beam is under links. You've got a little extra arrow and you can come down and there's structural and BHP sections. That brings up this old style menu. And let's go with UBs, and you can pick the actual size of the UB that you'd want to be using. So let's go with a 250 UB. So that beats looking up what size a UB is. We'll just turn that off, get it out of the way. And then if I was to turn that into a solid, while this is planes and lines, and it's all put into a set, with these arcs, you probably end up with too much detail in your solid that you probably don't want. So all I would actually do is you can just go in and use your solids to trace over, making your solids straight over what's already there, which is what I'm going to do. So I'm going to go with a 6 meter long member, and I'm going to use box by 3 points. I'm going to give it a height of 6,000. You start with a base point, a length that direction and a length that direction. I'm just snapping there. I can do the same this way. And let's go with the center that way. Just use my guidelines and snap. So I've just put in 3 boxes, of which I'm going to select all, go to an ISO view and go show. And you'll see that I've now got the 3 parts of the I-beam. And to join those together, when it's all the one material like this, the best tool is to union, and you select an item and then what you want to join to it. So what that's just done is created those 2 together, union, and I can select the 2 parts, and that is now one single member. There's your I-beam, 6 meters long. And I'm just going to make him visible in all views. So hold down the control and show. And I might go to a front view of that. So front, if I go to left, I can see him on the side. And let's say I want it to actually splice him off at an angle and have another member come out. Let's just copy this here. Let's pop him up the top. That wasn't such a great snap. Move him over. That was a copy again. I'm just going to delete that one out of the way. I would then just use rotate by 3 points. And let's say straight up. And we're going to go out on that angle. So to create a knee joint between those 2, I'll just jump back to ISO just to make sure that they're lining up exactly how I wanted them. That looks pretty good to me. So I could just, depends on the actual detailing I'm wanting here. If I want a fillet joint between the 2, I would do differently to if I actually want this bottom fin to run through and actually join onto here. So let's just go with a fillet join to start with. So we're going to go make sure our projector CPL is turned on and slice, snap here, snap there, and then select the solid section that I want to keep. Select the solid section I want to keep. And now I've got a fillet join between the two. I probably wouldn't union those two unless I particularly needed to, because while they remain two separate parts, I can then slice them, I can scale them separately to each other. If I union them, then it's all becomes one member. And then when I slice, I'll show you, for instance, if I go union this, and then decide that I want to slice, say, up here off on an angle. Let's slice there on that angle. This is the part I want to keep. Of course, it will slice right through the whole of the solid. Whereas if I hadn't have unioned them, that leaves me with the freedom to be able to slice this as a separate member. Or that was a bit of a cheat. Wasn't quite. I can slice that as a separate member. So keeping them as separate that way. But if I want to join them in a way that actually allows me to move them together as a single piece, of course, I can go to sets and create a new set. Don't have to call it anything in particular. Select the two items. And of course, that now gives you the two. Try show all, select all. The two items are now in that one set and moved together. The only trick with them being in a set is that they don't like to be sliced once they're in a set. So if you were to want to now slice that, you would just select it, go unpack set with a right-click menu, then do your slicing on the separate member. Now, of course, if you've decided that you now need an 8-meter long member for your vertical, how do you make it longer? Well, there's two different ways. One is that you can just go copy and bring it down, say another 1500, and union the two parts together. Sometimes that leaves you with another way of lengthening your member would actually be to use scale. Of course, with the angle splay, that's going to be an issue, but we will just scale it. We'll go X is 1, Y is not 20, let's go 2, and Z is 1. We're just going to then scale it from here up, move perhaps another 2 meters up, and then re-slice. As you can see, when you scale, that angle has changed. So you would then slice, just snap, and take that member. So that's a way of lengthening that. If you actually wanted a true section at 1800, really the only way is to cheat a little. Go copy, bring it across, go back to your left view, slice it at the height that you want it to slice at. Go back to my top. We can then go plane, change, solid, and let's make it 0.5 so that it's reasonably visible. Select that. Moves that back into play. And effectively that is like what Caddsman's doing in, normally when it's sectioning through a wall, it's effectively doing the equivalent to that, but automated. This doesn't automate. You can obviously group those things together so that the problem is that you'll end up with the line on the elevation of it. So you would want to hide the short part of that section in each of the other views besides your plan view. I said you may want to do different detailing here where you actually have the bottom coming straight through. Obviously, the way you would do that is, let's go move. You would take your steel section all the way through, extend it beyond your joint, and then you would slice. You would slice perhaps on that bottom back plate and keep this. You then have an issue that you've got a fillet that they might use for a weld, but if you wanted to even get rid of the fillet, you can slice from here across, keep this part. It's not liking me because I've got it in a set. I obviously picked the one that still had the solid color on it, and it's actually applied it to all of the colors when I did that slice to all the planes. Bring it back down, and then we can union this to this. There you go, reset it. And that's the different detailing there. We've got a little nip there. That's a little bit more of a challenge to get rid of. If you're going to go down to that level of detail, you would probably have kept the plates all separate so you can slice them all separate to each other. So that's sort of, in the real basic sense, that is the nuts and bolts of the fundamentals of solids. It's using some primitive shapes, unioning them, slicing them. You can actually do the intersection between, you can do the subtract from one from another. So if you wanted to put, say, a hole through the middle here, you would perhaps go cylinder. Let's go 2-point. Radius of the cylinder is 50. I'm going to give it a nice big hole. Center and end of the cylinder is Z 1000. So it's coming straight at us. You want to probably look at where that all sits in ISO for the show. Our cylinder's way over here because that's where our CPL was. Want to move that cylinder through so that it actually intersects. And then you would just go, instead of union, you would subtract, and just go difference between keep and take. And that gives you a nice little hole through your steel. There are a number of other things you can do as far as filleting and shape, filleting, scalloping, and under here you'll find there's a full notch, fillet, chamfer. Chamfers are probably one of the more useful ones, and full chamfer. So the difference between part chamfer and full chamfer, which applies to fillet and scallop as well. Let's do a 1 meter high. Give us a nice big chunk to work on. So if we, I'm going to make life really hard. So I'm really on a weirdo angle to the CPL. I'm just going to give that a go, see what we end up with. If we go chamfer, it asks us to locate the edge that you want to chamfer, that edge, and it will actually pick the two planes from that edge. So in this case, it's gone the vertical one first up. I want to go how far down that face. Let's go 300. How far across that face do we want to go? 600. Then it asks me for a start point. So I can just pick somewhere along and somewhere along, and it will actually chamfer back in. So that's then gives you the 300 in the vertical, 600 in the horizontal, and chamfer in from the start and end point. Of course, you can use your inline tools for distance along. So if you wanted to particularly start your chamfer, say 200 in from each end, we'll go with a fillet this time. We want to fillet the radius of 200, so it's really easy to see. It goes again, select the edge, select the start point. If I used the inline distance along, we can go in from that end 300, in from this end 300, and it will fillet through that length. The other alternative under here you'll find is full fillet, and full scallop, full chamfer. So the difference with those tools settings, let's go full chamfer. Full chamfer. Look at the edge, the chamfer, that edge, again, we'll go 100, 1000, and it goes for the full length of that edge that I selected, which is really nice in that scenario. What is interesting is that if you want to do that same fillet back on this other face, when I go full, it doesn't go the full length of the solid, it is only the full length of that edge. So if I do the 100, it stops at that intersection. So if I actually wanted that to fillet right through, I would actually not use the full chamfer. I would just use the normal chamfer and go chamfer, that edge, let's make it 800, 300. And I would start before the solid, finish after the solid, and it will go right through and give you a compound joint in that chamfer. And you can, as you can see, that previous chamfer did a compound joint with the fillet. If you're wanting, I'm going to change that to a different color. Let's just select the whole thing. Now, the whole of the solid has one color. So if you're wanting it to have separate colors, you need to have separate parts. And not union them, because union will actually make them the one part. If I'm wanting to apply a render material to it, I can, let's go with a color map, select a file, let's give it a, let's make it look like leather. There we go. Because I've got that in a sub menu, but I'm accessing it by a library, it's got textures is my library, but it truncates the whole of the path. I'm in a sub menu to that, so I've actually got to write the menu back in. Let's give that a 500, 2000 by 2000. Absolute, that looks pretty good. I'll apply that. That gives the leather to the whole of that solid, as opposed to if I'm going to apply a plain hatch. To apply that hatch pattern, plain change, copy, okay, and I can apply it to that surface and that surface. So the difference being that when it's a solid, the render properties is completely supplied to every face of the solid. When it's a hatch, it is only applied to the selected planes that you do. if you wanted to apply it to all faces, it's a little bit of a tedious task, but the very primary plane that it has, if you apply it to it, so if I go plane, change, copy, and I'm going to take a guess that it's the bottom, maybe it's the side. I'm just going to apply it to a few faces. There we go. Now if I do an edit, say slice through this corner, keeping that, because I got the primary face, which is the first face of the plane, when I did the edit, it actually picks up the properties of that one surface and applies it to every surface in your solid. One of the most common uses that I have for solids is when it comes to fencing, because union doesn't actually mean only the connection between two of the solids. You can actually union two solids with a space between them. So if I was to want a picket fence, for instance, I might start with a very simple rectangle, go 90 by 1200. So let's say that's our little picket that we want. Let's say that's what we want as our picket, with that being a hole. One of the simplest ways to do it would be to actually first up put a plane in by fill and just click in there. We now have our plane. Don't want the hatch on it. So if you're using on the side, if you're using the properties panel, these drop down. So that's our plane. We can use in solid, there is an extrude by plane. So we can go extrude by plane. We want our picket to be 20 millimeters thick, and we can select the plane, and that should have created a solid. Now we have our picket with our nice little hole in it, and we can start building our fence. So let's say we want 1800 between our first picket and our last picket. We're going to go copy. Let's go here. And of course, 1800 is going to be too far because it's not 1800 between the start and end one. Let's get a distance from here to here. 1890, I went 90 too far. Let's pull him back 90 mil. So our picket itself is 90 mil wide. And we're going to go, how many do we want? Let's go copy. And let's go. That looks about right, doesn't it? So now we just use the distribute tool or the alignment tool. And we go X, we're going to align equally spaced. Y, we're going to align the bottoms or the tops or not align them at all. In this case, they're already aligned, so let's not do that to them. We're going to select all of them, right click. And besides the grungy bits that I had there to start with, let's just go copy one more. I'm going to go move this picket, that point. I'm going to go inline reference from a distance. I'm going to go here. I'm going to go 1800, and that is now 1800 from that base point. So that was, all of them are equally spaced, well, except for these couple. So because I just used the alignment tool, I can just select them all and I can just go align and it will reapply those exact same settings. Now, what I normally do is once I've made up a panel like that, I actually go to solids and I'll often union them all together. It's a little bit tedious because you've got to keep selecting what you've, each of the things. Let's say I missed one. I can keep going. And I can then go union that and that. Now that is all one solid. With it all being one solid means I can pick it up, move it all as one panel. If I decide that, okay, we've got a ground line that is coming through like this. I want the tops to all align, but I want the ground to be following the ground. I can go slice just above the ground to just above the ground. Keep this part of the fence. And there's my fence following the ground line. So I can then just go slice, and I can slice in the gap. Keep these two. I'm back to 2 pickets. And then I can actually union them into the set if I like. Or if I wanted to pick it out by itself, I can just copy that off and go just slice away all the rest. And I've got one that I can use by himself. I might want to, if I was, the other way of doing a picket fence, of course, is rather than slicing them, would be to follow the ground line. So I can go, in that scenario, you'd move him up to the ground line. Let's pop his ground line over here. We're going to copy multiple times this time. We're just going to go copy 10 times from here. We want 10 mil difference, 20 mil gap, make him 110. There he is. I can move that one up to the right level. And I should be able to then go, let's move him over here. A little bit more of a gap we wanted, say that. Go align. This time we're going to go equally spaced in the X. In the Y, we're going to go distribute top edge. I'm going to go here, here, here. And so that distributed the top edges equally on the way up, and it's distributed them with equal spaces. And so that gives you your picket fence that follows the ground. The other one that I use a lot, I showed you guys last time, was I have got just some bits and pieces of a stair that I've made. So I've got a stair. I'll just cancel out of that. Unpack set. So you'll see the 3 separate parts that I've made. What I did is I actually made, so what I've done there is I just started with a stringer and a tread. I then put in a solid and trimmed and subtracted out the end here, sliced the end, trimmed it over so that it will sit nicely on my deck, which I use a floor for the deck. And this just sits in nicely. And then the other end of the stringer, I just trimmed and sliced, put in a tread at a consistent height, and then unioned it all together. Well, sliced it into parts and union the parts together. So then have the different parts of the stair, the top, the bottom, and the middle. And then doesn't matter how many stairs I want, I can just go move that over there somewhere. I can go copy this guy to here, to here, to here, get rid of that one, move the last piece into place. So now I've got a 5 tread high stair, and I go back to solids and I union them. And just make them visible in elevations and plan where I want to. And I've got myself a nice little customized staircase. If I wanted him a bit wider, I just scale it. If I wanted it a little bit higher, I scale it in the Z direction. And that just gives me the, you know, if you start with something that's pretty close to where you commonly use it, I think this is how wide's this one? I can measure the length of that edge. So it's 1150 wide, it's 1250 overall. If I go, I actually want it, I go scale. The only trick is I want to see which way X is. So I want to scale it in the X. And scale X, 0 point, paste, which I got off the clipboard off the calculator, Y1, Z1 from that side, and now I've got a 900 wide staircase. If I was going to put some cables through there, I probably would just go with my 3 point, make him 10 millimeters high, from here to there, and 10 millimeters and snap down here. That gives me a little 3D cable, too long, so I can then go slice and slice the first one, keep this bit, slice the second, oh, slice the second, that gives me a cable through there, and then I can go copy 100. You might go, why would you want to do that rather than just use lines? If you actually want to see though, if you're going to do a rendering, your lines don't show up in a render. Whereas if you do them this way, you can render it and see your cables. We'll cast shadows. We'll be able to see in an array trace. You can actually apply a property to them. Yeah, so a few advantages in doing it that way. And again, if you union them together, you can do the slice of them all in one go too.